Hello, I'm Brian Watrous of VMware Education. In this segment, we'll look at how to use VMware vSphere HA to protect virtual machines. VMware vSphere HA protects virtual machines from three types of failures. We'll protect you if the ESX host the VM's running on fails, if the guest OS inside the VM fails, or if an application inside the VM fails. So in this slide, we take a look at the first of our three failure scenarios. This is the scenario where the ESXi host itself crashes or loses power. As you can see here, to protect us from this type of failure, we need to first set up a HA cluster, which we illustrate here with the green box. In this HA cluster, we have three hosts. In the world of clustering, we'll refer to those as nodes. So here we have a 3-node HA cluster, and as you can see illustrated with the orange arrows, there is a heartbeat that's sent between the nodes in this HA cluster. And notice that for host failure detection, the heartbeat's being sent between the hosts. In order to have an HA cluster, you need to have the hosts involved managed by the same vCenter server, and the hosts need to be able to see the same shared storage. It's in that shared storage where the virtual machine files need to reside. Now, if a failure should occur, for instance, if the host should crash, or if a host should lose power, then the host will crash, along with it the virtual machines on that host. But notice that because the heartbeat's no longer being sent from the crashed ESX host, the other two hosts, we'll call those the surviving hosts, the surviving hosts can see that the other host is no longer alive. And after a configurable amount of time, roughly 30 seconds, those two surviving hosts will restart the affected virtual machines. The second scenario that VMware HA protects you from is if the guest operating system fails. And notice that the general setup here, the general configuration, is essentially the same as before, but when we're performing guest OS failure detection, the heartbeat that's used in that case is sent between the virtual machine and the vCenter server, whereas before the heartbeat was sent between the hosts. If a virtual machine or the guest operating system within that virtual machine should hang, then the VMware tools, which is installed in the virtual machines, will also hang, which will result in the heartbeat no longer being sent to the vCenter server. Once again, after a configurable amount of time, the vCenter server will detect that the heartbeat is no longer being received from the virtual machine, and in response, the vCenter server will restart that virtual machine. In our third scenario, VMware vSphere HA is going to protect us from application failures. And much like the previous scenario, the heartbeat that's used in this case is sent between the vCenter server and the application itself. Once again, if in this case an application were to die, then the heartbeat that the vCenter server had been receiving would no longer be received, and the vCenter server will respond by restarting not just the application, but the entire virtual machine restarts, followed by the application. In this demonstration, we will set up vSphere HA host failure detection. To do so, we'll begin by switching to Host and Clusters view. In Host and Clusters view, we will right-click the training data center to create the HA cluster. Notice just before we do so that I have two virtual machines, and currently they're running on the host called ESXi01. But let's continue creating the cluster by right-clicking our data center object and choosing New Cluster. We begin by naming the cluster. I'll choose the name My Cluster. And then in the following two checkboxes, we can specify whether we want a VMware vSphere HA cluster or a VMware vSphere DRS cluster, or by checking both, we could create a cluster that performs both HA and DRS. We'll begin this demonstration by simply enabling vSphere HA. And notice in the left side of this wizard interface that once we clicked vSphere HA, a few new entries were added into the list of topics or on the left side of the screen. And we're going to proceed through those, starting with vSphere HA. The first checkbox that we see up top here is used to enable and disable host failure detection. When you first create your when you first create your HA cluster, it would be sensible to leave the checkbox checked because you're setting up the cluster. Later on, though, after the cluster has been up and running, you'll want to remember this checkbox. For instance, if ever you're modifying or performing maintenance on the heartbeat network that we discussed previously, you want to make certain that you uncheck this checkbox before performing that maintenance. Otherwise, you can create false alarms that vSphere HA thinks are being caused by host being crashed. So again, when you perform maintenance, make certain that you uncheck this checkbox first. In the following section, under admission control, you can set up a policy that specifies whether or not VMware should reserve capacity on each of the hosts in the cluster. Now, as you can see, the default is to leave admission control enabled, which will cause us to continue to do as we ordinarily do, which is to reserve capacity. You can disable admission control, thereby instructing us that we need not reserve excess capacity. But in an HA cluster, in general, you need to reserve capacity. So I'll leave this radio button labeled enabled selected for now. In the following section, you can choose from 3 different policies that say how we reserve capacity. In the first choice, you can choose a number between 1 or 4 to indicate how many hosts you want to be able to fail in your HA cluster. An HA cluster can have up to 32 hosts. Here we can specify that up to 4 of them are allowed to crash, and the cluster will still continue to protect us. Now, 4 hosts is certainly a large number of hosts to have crashing. I can certainly hope you don't have that many crashing, but up to 4 is the valid number that you can type here. As an alternative, you can choose to reserve an explicit amount of CPU and memory capacity on each host. Here, for instance, we're reserving 25% of the CPU and 25% of the memory resources on each host. As a third choice, you can choose to specify 1 or more standby hosts that act as passive hosts awaiting a failure to occur. If a failure occurs, then the VMs, when they're restarted, will be restarted on the host that you specify here. Now, this option is grayed out right now because we don't have a cluster up and running yet, but if we create a cluster, then come back into this wizard interface, you can enable 1 or more passive hosts. Again, passive hosts are generally not the approach most customers should use. Passive hosts are useful in environments where regulatory compliance issues mandate that VMs and the location of VMs need to be known at all times. But for most customers, choosing either the default host failures or percentage of cluster resources are the options that you should go with. I'm going to go with the default, which is host failures. We'll tolerate the loss of up to 1 host. We'll click Next. And in the following screens, you could further configure your HA cluster, which we'll show later on in this demo. But for now, I'm simply going to skip through the remaining portions of the interface here and create my cluster. Notice as we do so, in the recent task section, it tells us that we've now created a cluster. In order for that cluster to actually protect us, however, we need to put the hosts into the cluster, which I'm going to do by simply dragging and dropping the hosts onto the cluster object. Now that we've created our vSphere HA cluster, let's simulate a failure of a host in that cluster. To do so, let's first find out where these virtual machines are running. We have 4 Windows 2003 server VMs, and if we select the cluster, which we already have, then go to the Virtual Machines tab, we can see exactly which host each VM is running on by looking at the host column. To simulate the failure of a host, I'm going to shut down a host. Since these VMs are currently running on ESXi01, that's the host that I'm going to simulate a failure upon. To simulate the failure, I will right-click the host, then choose Shutdown. Notice just before I do, though, that there's an entry in this pop-up menu labeled Enter Maintenance Mode. The proper way to shut down a host that's in an HA cluster is to first put the host into maintenance mode. In order to simulate the failure, though, I'm going to purposely neglect to do so. So I'll select Shutdown, and notice we're warned about the very issue that I just told you about. We need to put the host in maintenance mode before going into shutdown mode. But again, to simulate the failure, we will not do so. Instead, we'll simply shut down the host. I'll list the reason is that I'm testing vSphere HA. And now we'll simulate the failure. As we watch the events unfold, keep an eye on host ESXi 01, and on the right side of the screen, if you keep an eye on which host each VM is running on, we should see some interesting things happen in a few moments here. Notice that the host that we've crashed has now turned red. It's furthermore grayed out along with its virtual machines because that host has crashed, and therefore we currently don't have the ability, well, actually, that was very quick. We have the virtual machines being restored, and if we take a look on the right side of the screen, we can see the VMs are being restarted on host ESXi 02, and in fact, they are all now powered on, and the guest operating systems within those virtual machines are currently booting up. So we have successfully demonstrated our VMs have recovered from a failure of a host in our HA cluster. Now that we've configured and tested our vSphere HA cluster, let's take a look at a few advanced configuration parameters. Just before we do, one quick thing that you may have noticed is that our two hosts in the cluster are currently displaying yellow warning icons, and in fact they've been doing so since the beginning of our demonstration. The reason why that's occurring is revealed on the Summary tab for the hosts. If we select either of those hosts, then go to the Host Summary tab, you'll see a message to the effect that the host we've selected currently does not have management network redundancy. Now, for a proof of concept project, having this network redundancy is not absolutely essential, but it is a recommendation for production environments that you have management network redundancy. We'll talk about this issue in a few moments, but for now, let's look at those advanced configuration parameters. Now, previously, we've already created our cluster, and I'm going to simply go back and edit the settings for the cluster. Again, our cluster is an HA cluster. When we answered the first questions as we set up the cluster, we were asked whether or not we wanted host failure detection turned on. We said yes. Furthermore, we said that we wanted to continue to have admission control enabled, which causes the vSphere HA cluster to reserve capacity. We additionally specified how we wanted that capacity reserved, and then because we did not, in our demo, need to do any further configuration, we simply proceeded onward without answering any further questions. But as you can see, there are additional questions in these sections over on the left. If we go to virtual machine options, you can see that we have the ability to specify for our HA cluster priorities for our virtual machines. As they restart, some virtual machines are quite likely more important than others. Some virtual machines, for instance, are infrastructure VMs that need to start before others. So we have the ability to affect the priority of the various virtual machines as they're restarted. And furthermore, we can specify a policy for something known as host isolation response. Now, up top here, you can see that our restart priority is set to medium. And while you could set the restart priority to other values, typically you'll leave the default priority set to medium. And then what you can do is go to individual virtual machines down below and, as needed, change the policy for that specific virtual machine's restart priority. For instance, our cluster default priority is medium. If we have a virtual machine that is of more importance, a higher importance VM, perhaps an infrastructure VM, we could select high for it. For other virtual machines that are of a lower priority, we can set their priority to low. And if there are virtual machines that aren't as important and perhaps aren't important at all during an HA host failure, we can specify that we would like that particular virtual machine disabled. When you choose disabled, that means that the vSphere HA cluster will not restart that virtual machine in the event of a host failure. So again, at the cluster level, we can set a default priority, which we can override on a per VM basis. Host isolation is an issue that can sometimes arise, far less frequently in vSphere 5 for reasons I'll point out in a few moments. But host isolation is something that can possibly occur. We'll discuss in a moment what that is. But notice that the default policy for the cluster is that if a host isolation event occurs, the host that's been isolated will leave its virtual machines powered on. Now you can change that policy if you so desire, but VMware's recommendation is that you leave the VMs powered on. Again, on a per VM basis, you can override that policy. You could say that, for instance, this virtual machine should be powered off during a host isolation event. Again, these are all configurable and up to you to decide how to best configure them for your particular environment. Under VM monitoring, we have the ability to specify whether or not we want virtual machine monitoring turned on and optionally also application monitoring. You'll recall that there are three types of failures that VMware HA protects us from. The first, the one that we've already configured, is host failure detection. If we want to also detect when the VM or guest OS has a problem, we can choose this option. And furthermore, if we want to detect both VM guest and guest OS failures and application failures, we can choose this third option. To illustrate, though, I'll turn on VM monitoring only, and you'll notice that down below we can set up a cluster-wide policy that says how sensitive we want to be to detecting VM failures. And we have three slider positions, low, normal, and high, which assign pre-assigned values to the parameters you see listed on the screen here. Or if we choose custom, we can set the values to any value that we desire. The first value, failure interval, allows us to say how long the vCenter server will tolerate not seeing the heartbeat from the virtual machine. So after 30 seconds, the vCenter server is going to respond by restarting the virtual machine in this particular case. In this second field, we're able to specify that the vCenter server should not pay attention to the heartbeat for the first, in this case, first 2 minutes. If you imagine a virtual machine booting up, the virtual machine booting is followed by the guest OS booting, which is followed by VMware tools starting. And that can take certainly over a minute for all those events to occur. So by introducing a 2-minute delay, we're preventing false alarms while the VMs boot up. And then the final fields that you see here allow us to specify if the vCenter server is restarting virtual machines, how many attempts it should make at doing so and over what period of time. Again, up top we have a cluster-wide setting which can be overridden down below on a per VM basis. And then finally, in the data store heart beating section, we can specify data stores that we want to use for heart beating. Previously, we discussed that the heartbeats that are sent between hosts is performed via a network connection. And that's true and has historically been true of vSphere 4 and other such products. In vSphere 5, we've introduced the concept of data store heart beating, which provides us for a more robust, more redundant heartbeat mechanism. So that, for instance, if the network heart beating fails, we can still detect whether or not a host has failed based on its data store heart beating. Now, I don't want to actually change my cluster with the settings that I was just demonstrating, so I'll click Cancel, and this will end our demonstration. One of the issues that we raised during the demonstration is the importance of the heartbeat network. In vSphere 5 and preceding products, we've had a network heartbeat capability. In addition, we now in vSphere 5 have the data store heartbeating mechanism. As before in previous releases, in vSphere 5 it's recommended that you implement redundancy in your heartbeat network. We can see that illustrated in this particular slide. Notice that we have a virtual switch and that virtual switch has been NIC teamed. This virtual switch has multiple physical NICs. Therefore, a failure of one physical NIC won't prevent the heartbeat network from running entirely. Furthermore, we've created multiple VM kernel ports, each being used for sending heartbeats. Again, by implementing this redundancy, we can prevent false alarms and prevent host isolation events. VMware Education Services offers training in over 500 training centers across the world in 60 different countries. We offer both direct training and training through our VMware Authorized Training Centers. We offer instructor-led training in both classroom and live online formats. We offer private on-sites and e-learning modules available online. To find out more information, please see us online at the URLs listed on the screen. Thank you.